What is going on, everyone? New homework number 24. Today's objective, I can write equations of perpendicular lines. Yesterday we did parallel. Today we're going to dive into the perpendicular lines. Let's take a peek. So the big thing that we're going to need today is to go back to this term reciprocal, and it should be obvious definition for us, or an obvious idea for us. We've dealt with reciprocals a lot. Here we go. So reciprocal is the reciprocal of a number is 1 divided by that number. All right. We also know it as sort of flipping the number, so flipping the fraction. But flipping obviously doesn't always work, especially if you have a number like 2. Okay. So I want us to get the idea that the reciprocal of 2 is simply just 1/2. The reciprocal of 3/2 is 2/3. And the reciprocal of -1/5 is -5. Okay, so they are reciprocals. I am essentially flipping the fraction. Now, I know that is how we're used to seeing it. If that helps you, use it. Okay, reciprocal is going to be key today. All right. Yesterday, we saw that parallel lines had the same slope. Today, we are going to see that perpendicular lines definitely don't have the same slope, but they have an interesting relationship with their slopes. So let's take a look. So make sure you have all of these notes down as I'm working. Perpendicular lines are lines that intersect to form right angles. And I know the right angles are a little bit difficult to see right now, but they would be right here, right here, right here, and right here. Okay, so we have right angles all around those. All 90-degree angles are going to be made from these perpendicular lines. Okay, so the interesting thing about perpendicular lines is seen right here. Perpendicular lines have slopes that are negative reciprocals of each other. I'm going to say that again. They are negative reciprocals of each other. So their slopes are not the same like parallel lines. Their slopes instead are negative reciprocals. So here are the examples. So this line number 1 that we have here, this line right here, the equation that fits that line is y is equal to -4x plus 1. -4x plus 1. The line that is perpendicular to it has the equation y is equal to 1/4 x minus 2. So their y-intercepts could be different. That's fine. They could be almost anything in this sense to make the perpendicular lines, because we're not giving specific point values. But their slopes, notice, are negative reciprocals of each other. So -4, the negative reciprocal of -4 is positive 1/4. Okay, so these are negative reciprocals of each other. Before we get into working on any problems like the parallel equations yesterday, we are going to get to some identifying negative reciprocals. So just so we can get used to it. So I'm asking you to identify the negative reciprocals of each number. So the negative reciprocals of each number. So we start with 5/2. The negative reciprocal of 5/2 is going to be, well, it's positive 5/2. So that means that the negative reciprocal is going to be negative. Reciprocal means we're going to flip that fraction to 5ths. Okay. -2/5 is the negative reciprocal. All right. -6. The negative reciprocal of -6. So we know it's going to be positive, because negative means opposite. It's going to be positive 1/6. All right. The negative reciprocal of -1/9 is going to be a positive 9. And the negative reciprocal of positive 1 would technically be -1/1, which is simply just equal to -1. All right, so just a little introduction to negative reciprocals before we dive into these problems. Are you ready? If any of you said no in your head or out loud, I'm going to ignore it. Let's go. So our steps for writing these, same as the steps for the parallel lines. The only difference is going to be that step 2. We're going to write a new equation in slope-intercept form with a slope that is a negative reciprocal of the given slope. All right, and then we're going to do the substituting. We're going to find what the y-intercept is. Then we're going to write the new equation. So let's go. Write the equation of the line that passes through the given point and is perpendicular to the given line. So let's do it. Is our equation in slope-intercept form? It is. Y is equal to mx. We don't know what the plus b is. The plus b is actually plus 0. But we don't see it right now, which is fine. So let's go right to it then. Let's label our x, our y, our m, and our b. This is where we need to be careful. We're talking perpendicular lines, not parallel lines. So our x is -6. That's what they give us. Our y is -3. They gave it to us. Our slope here is -2/5. But the slope that we want to make, fix that. The slope that we want to make needs to be the negative reciprocal of -2/5, which is going to be a positive 5/2. All right, we're looking to make the negative reciprocal because we're looking for perpendicular lines. Our b, I don't know yet. So let's go. Let's make it happen. So -3 is y is equal to our m, which is 5/2. Let me make it blue for us just so we could see it. 5/2 times x, which is -6, plus b. I don't know what b is yet. So -3 is equal to -6 times 5/2 is -30/2. I'll simplify that in a moment. Plus b. So -3 is equal to -15 plus b. I'm going to solve for b and add 15 to both sides. 12 is equal to b. So let's write the equation. So the equation that is going to be perpendicular to this line that goes through the point -6, -3 is going to be the equation y is equal to 5/2 x plus 12. All right. Let it sink in. Let's go to another one. All right. So let's see first. Is our equation in slope-intercept form? Doesn't look like it. So let's get it to slope-intercept form. I'm going to subtract 3x from both sides. -4y is equal to -8 minus 3x. Divide both sides by a -4. We'll have that y is equal to 2 plus 3/4 x. Rewrite it in slope-intercept form. Y is equal to 3/4 x plus 2. Okay, first step done. Second step, let's make it happen. Let's label x, y, m, b. So let's go. X is 0, y is 3. Our m, we want it to be the negative reciprocal of whatever our slope is right here. So our m is going to be -4/3, and our b is a question mark. We don't know yet. So let's put it all into a linear equation. I'm going to do it right down here. 3 is equal to -4/3 times 0 plus b. Nice, easy for us. 3 is equal to 0 times -4/3 is simply just 0 plus b makes it b. Therefore, our equation is going to be y is equal to -4/3 x plus 3. This equation is going to be perpendicular to this equation and go through the point 0, 3. All right, nice. Last one. All right, so this is one of these special case ones, similar to like the one we saw yesterday. So for this one, because it says just x is equal to 3, I'm going to draw my little coordinate grid here. I know that the equation for x equals 3 has to be right here. All right, where x is 3. All right. So the coordinate -2, 5 would have to be, I would go over 2 units and I would go up 5. So it might be somewhere, it's not drawn to scale at all, but somewhere right around here. All right. I went over 2 units and I went up 5 units. 1, 2, 3, 4, 5, right? Let's say. I know that that's not drawn the best, but that means that I'm going to be making a line that is, let's redo that one. I'm going to be making a line that is horizontal. And the only horizontal equation that's going to make this happen if I'm going through my y-intercept, if I have a y-intercept of 5, needs to be the equation y equals 5. All right, that one I'm not saying to do any calculations. Make another line down here just to make it a little bit better. 1, 2, 3, 4, 5. No calculations done, but that's the only one that's going to make a perpendicular line. Horizontal lines and vertical lines are perpendicular to each other. So this is the only equation that is going to go through this point and be perpendicular to x is equal to 3. I know. It's fantastic. I love it too. Let's do this so that we can get to some practice tomorrow. Can't wait. Super excited. Think I could smell an exam coming soon. Get to those practice problems, and I will see you all tomorrow.